Hello, welcome to today's Leak Code problem solving session. Today's problem is 330 patching array. So let's read the problem out. The problem is given a sorted integer array nums and an integer n, add slash patch elements to the array such that any number in the range 1 to n inclusive can be formed by a sum of some elements in the array. So basically they're going to give us an n and then an array. And what they're trying to say is uh, using the elements in the array, we need to like find sums using the combination. We need to be able to find every number from one to like here six, inclusive of six. So here the answer they say is one, and kind of the explanation they gave. So like if you just use one, uh, it's one. You have three, and one plus three is four. So what's missing? There's two missing. There's three, four missing, five missing, and six missing. So basically, they are two nums, and they say that since you have one, two, three, and one plus three, two plus three, and one plus two plus three, they have all the elements that they need. Now you have one, five, 10, and they say that like two and four you can find all numbers between 1 to 20. Can we reuse the numbers? That doesn't make sense. Uh, Okay, I mean you have one five, 1 2 5 4. So like let's say how if you want 17, okay, so that's gonna be like 10 plus 5 plus 2, yeah. And if you want like 13, that could be like 10 plus 3 plus 1. So the constraints here are like we have 10 thousand numbers, 10 to the power of 3. We have nums I in the range of 1 to 10 power 4, and nums is sorted in ascending order. So basically, the approach that's running in my head is some sort of binary search, mainly because we have a sorted array, so the array is already sorted. It's not exactly big, but I think this is just a hint to be able to find this thing. And hmm. So I guess we could like start with six. So we look for six, and we break six down into like one and five for one plus five. Since there's no five, we break down since we're already looking at one. The thing is, my idea is like breaking down n into like just trying to find n first and then like n by 2 first or something like that. Or one more idea is like trying to find all numbers, I guess. That's one way. But the thing is, if we don't have a number, how do we find the smaller number, right? So, like, if we don't have six, how do we break it down? And how do we break it down in such a way that we don't like basically break down two into one plus one, because we're looking still for unique numbers. Oh yeah, yeah. Okay, great. So actually, it doesn't need to be unique. Yeah, doesn't need to be unique. So, but I guess we still have to be careful of keeping the count of how many like sort of numbers we're using. So if you have five, so that will be like, yeah, I mean sum is five. Now how do we search for it, right? Do we break it into like one comma uh, four, and four is like one comma like, so we don't want to do that. So then we'd be adding um, four values. So we try for like one comma two, you know, uh, yeah, I think easier, like at least better than maybe it's the pattern that I've been noticing in the problems the last few days. But having a count of all the numbers in the array would be like one sort of thing. Yeah. Let me like think for a second. Yeah. I guess I'm just gonna do a like count all the numbers and then like basically do some sort of like backtracking. Yeah, but then we gotta like find the minimum for all of them also. Hmm. Let's start coding and think. Nouns, and guess I need to like do DFS backtracking, whatever you wanna call it, like knapsack, I guess. Yeah, maybe let's just call it knapsack. Hmm. Mm. My question is, do we like memorize something, or like cache something? Because how do we keep track of like what numbers that being used? Let's not do that. And I guess. No, I'm gonna like. I think I'm just gonna look at the solution, try to come up with that. Because yeah, no matter what I think of, it has some logical error on building up the eventual solution, the final solution.